This is the first e-learning assignment for Geometry Basic. We'll be working in our note packet that you brought home on Friday the 13th. Those of you guys who weren't here, I emailed you a copy of it. You could try to print. There's one on this webpage, or you can just wait because I just physically mailed you a copy if you weren't here to get the digital copy. And what we're doing in this note packet is trying to calculate area. In fact, the first question asks you, what is area? You can Google it, go with an official Google definition, but it might be actually easier to look at question number 2 to get your answer for number 1. I want to know what the area of this fish is. And the way what I mean by finding the area is each of the lines on the graph can correspond to drawing a little box in here for the fish. And what I'm asking you for area is how many of these little boxes fit inside this fish. So you can draw in all these boxes. You don't actually have to draw them. You can simply imagine them. So whether you draw it or not, you're trying to count up how many of these boxes fit inside this shape or whatever the other shape. And that's what the area is. Area is how many boxes of whatever size. They could be squares that are 1 foot across or 1 centimeter or whatever. But how many squares fit inside an object. That's what area is. That's what we're measuring. So for your definition, you can write that, or you can go to Wikipedia or wherever else and get a formal definition. For this fish problem here, you're literally counting up the boxes and reporting how many little squares are in it. It's not a big deal if you miscount by 1 or 2. In fact, I expect most of us do. You should be close to the correct answer. Then on the bottom of this page, we're going to talk about specific shapes, and everything is based on rectangles for this class. In fact, not just this class, but all geometry. When we talk about area, it's based on rectangles. What we'll do is, when we talk about other shapes, we'll simply discuss how those shapes are related to rectangles and change our rectangle formula to adapt for triangles or parallelograms or whatever the other shape is. We'll figure out a formula for its area by figuring out how it's different from a rectangle. So rectangles are a basic shape. What makes the rectangle important? What makes it different from the other shapes? Well, a rectangle is a quadrilateral with 4 right angles, and it's those right angles that are going to make it different. That's what we care about. All right, the formula for area of a rectangle, you should already be familiar with this. You learned it a couple different ways. It's either base times height or length times width, B times H or L times W. Doesn't matter which one. But I want you to write down a formula here and write down what the letters stand for. And we'll move on to page 2. So on page 2, we've got both those formulas listed as well. And they both work. It doesn't matter which way you talk about it. The one problem is later in the semester, the word base is going to mean something else. So I'm going to try to say length times width, but it's the same thing as base times height. When we identify our base and height or length and width, the way we can tell which 2 numbers are, number 1, the key thing here is they have to make a right angle with each other. And that's what I'm asking about right here, is when we're identifying our base and height or length and width, they must make a right angle with each other. All right. Now down here, we're actually going to do a couple quick calculations, find the area of these 2 objects, no problem. In this shape, this is a rectangle, all right angles, and it says so right there. So we're going to find the area, just simply multiply length times width or base times height. Find the area for number 7 and write it in here. Now when you do that, you got to remember what you really calculate. Like with the fish on the front page, we're counting how many squares fit in those rectangles. So on the second page, when you're doing problems 7 and 8, what we're finding out is how many little 1-inch squares fit inside the object. So whatever number you get, your answer is going to be some number. So your answer is something square inches. You're going to give me some numbers, a relatively large number when you multiply these, and that result is in square inches. That's how many 1 square inches fit inside that shape. For problem number 8, same thing, except this thing isn't just a rectangle, it's also a square. So if this side's 14, then this side's 14, this is 14, this is 14. And in this case, we're going to be giving our answer in square meters. You're simply going to multiply length times width or base times height. For problem number 9 here. All right, this one's a backwards problem, not a particularly tough one, but we will have some harder ones. In this case, it tells us the length is 8 and the area is 48. What it's not telling us is what's the width. So we have to use one of our formulas, either length times width or base times height. So here I'm using area equals length times width. I'm going to plug these two numbers in and solve for the missing number. 48 is going to go in for the area. I'm going to put 48 equals, and I'm going to put 8 in for the L. And I don't know W, that's what you're going to solve for. It's an easy Algebra 1 problem. On the bottom here, we have a kind of a weird problem. What you'll notice is we have two rectangles that are actually the same. 2 feet is 24 inches. 3 feet is 36 inches. So these two rectangles are actually the same, but we'll get some different measurements, because in one, our measurements will be in feet, and then area will be square feet. And the second one is in inches, and our area will be square inches. And what happens is not exactly what a lot of people expect. You can answer question number 10 pretty easily, and 11, you'll get two different areas here. Even though they're the same, we have 1 in feet, again, 1 in inches. And you should know that there are 12 inches in a foot. If you didn't know that, there's going to be 12 inches in 1 foot. But when we get the area for the second shape, it's not 12 times more than the area of the first shape. So when I ask you how many times greater it is, what you need to do to find this is find the area of the second shape, the second rectangle, the one where you have a larger number, and divide it by the area of the first one. And what you'll get is a number that's not 12 times bigger, but 144 times bigger. Why is it 144 times bigger? Well, in the first one, you're going to multiply 2 times 3, and you get 6 for your answer here. In the second one, the 3 feet becomes 36 inches. So to multiply that, to turn the feet into inches, you have to multiply by, sorry, I cut that off, multiply by 12. And then you have to do the same thing to go from the 2 feet to the 24 inches. You have to multiply that number by 12 as well. Then when we calculate area over here, we're multiplying these two numbers. So really, we're multiplying by 12 and 12 again. So you multiply by 12, and then you multiply by 12, which is why when we talk about how many times bigger the area is, the bigger shape down here, we're not simply going to get 12. We're going to get 12 times 12. All right, this should be enough for you guys to complete page 2 in the note packet. All right, finally here on page 3, we're going to talk about perimeter. Perimeter is really simple. What is perimeter? Well, perimeter is the distance around the outside of one of these objects. Doesn't matter which one, but that's our definition. So for the first one, if I want to find perimeter, I'm simply going to add up the distance you'd have to walk if you walked around it. So here's some little stick figure guy who's going to walk around this rectangle. He's got to walk here, and then here, and then here, and then back. How far does he walk? Well, it's really simple. We simply add up those distances. And you do that for all these shapes. Even though some of them, like number 4, is concave, we don't like that, but we can find perimeter easily even with concave shapes. So you should easily be able to finish this part of the assignment. Down on the bottom here, whoops, where area of composite shapes, I'm just going to ask you to go to Google, type in the composite shape, type in that word, and go to images and look at what composite shapes are. Find 2 pictures and just draw them there. There's already some composite shapes on this page, but I want to make sure everybody understands it. The word composite means putting more than one thing together, like 2 shapes put together. So once you finish that, you are done with page 3 and completed the first e-learning assignment for Geometry Basics.